Hey guys, so on Thursday we talked a little bit about moles and you guys wrote down that a mole represents Avogadro's number of particles. A particle can be anything that is really tiny, atoms, ions, molecules. And in order for us to do conversions from moles to particles or vice versa, we're going to need Avogadro's number in the conversion. Because in a lab setting, we're also going to be taking measurements of substances, and that will be in units of grams, we'll also have to use a different kind of conversion where we're going to use the molar mass of something. So molar mass comes from the periodic table. Molar mass is in units of grams per 1 mole of that substance. You simply find that element on the periodic table, and that number, that decimal number, is what the molar mass represents. So you would just use that in a conversion. If you just have one element, then you just find that one element on the periodic table. If it is a compound, which means if you have more than one element, then you're going to have to add all of the components of that chemical formula together, for instance, water, and not to belittle anybody, but just in case y'all have forgotten, because it's been a minute, when you see more than one capital letter, that's going to be your clue that you have more than one element. So some elements can be a capital and lowercase, but if it's more than one capital letter, then you're going to have more than one element. So this is water. You have 2 hydrogens, 1 oxygen, and you would add 2 hydrogens plus 1 oxygen together to get the molar mass of that entire chemical formula. For calcium hydroxide, I want you to notice that calcium, you're given just Ca. There's not a number 1 that's ever written in the formula, but there's 1 calcium. And then you have oxygen and hydrogen in parentheses with a 2. That 2 is just distributed to just what's in the parentheses. Okay, so you'd have 1 calcium, 2 hydrogens, 2 oxygens, and you would find the molar mass that way. All right, so if you needed to copy that down, you could have just paused the video. So now we're going to convert from moles to particles and vice versa. And instead of giving you like steps to solve this, because it's pretty straightforward, we are just going to start with an example. Okay? So we're going to do an example here, and so y'all can go ahead and continue copying this. And this is going to ask how many atoms are in, and then today is the 11th, so I'm going to do 1.11 moles of lithium. Okay, so as you're copying this, I want you to notice that this is just a word problem, okay, and we are given a quantity of 1.11. The word that follows the number given is your unit. And so this is giving us moles, and then we're going to have to solve for atoms, okay? So what we do in every single conversion is copy down. Now, I'm going to show y'all the thorough way. Some of y'all might take shortcuts, and that's fine, but I'm not going to show you the shortcut way. I'm just going to do the way that's more thorough. So we copy down what's given, 1.11, with the unit. Okay, excuse me, that is moles. And we're going to set up a conversion. I don't know why I keep trying to write atoms, because that's not what's given. And so our conversion, we're always going to multiply by something over something. Okay, so this is just a conversion factor. So I know that I'm starting with moles, and then I need to solve for atoms. So I know I have mole and atom somewhere in this conversion. Every time we use mole in the conversion, it's just 1 mole. Well, I'm starting with the unit of moles, so I need moles in the denominator so it can cancel with itself. Okay, so in my denominator, it's going to be 1 mole. I'm always going to use a 1 with the mole in my conversion. The number of atoms that make up a mole is Avogadro's number. So what's that again? 6.02 times 10 to the 23rd. You were in the ballpark. Okay. And that's going to be atoms. Okay, so mole is going to cancel. And then to solve this, you are going to multiply 1.11 times 6.02 times 10 to the 23rd. All right, what answer did you get?
I got 6.68
Times 10 to the 23rd. And do we round the 8 up, or does it stay as an 8? Okay, sweet. All right, and so this is our final answer, 6.68. We'll just go to 2 decimal places, times 10 to the 23rd. And then don't forget to write your unit with your answer. When you take a quiz, possibly tomorrow, you need to make sure that every answer has a unit. Okay? All right, so that's starting out with the number of moles given in your solving for atoms. Let's try the reverse direction. Can I scroll up? Okay. So next example.
What was that answer?
It is 6.68 times 10 to the 23rd. I can leave it like that. Not what? How many? So, how many moles make up? Emma? Can you give me your date of birth, the month and the day? I usually just pull. Okay, so 4.10 times 10 to the 20th. We'll do molecules of, let's see, we'll do W. Isn't your last name? No, your last name is Brown, isn't it? Okay, we'll do bromine. Br. All right. So, how many moles make up this many molecules of bromine? So, you're given a problem. Again, you've got a particle in the problem, so we're going to have to use Avogadro's number. We're just going to set it up a little bit differently than before. And we always zone in on the quantity given and its unit, and we write that down first. So, 4.10 times 10 to the 20th molecules. By the way, there is no abbreviation for the word molecules. But guess what is abbreviated? Guess what has an abbreviation? The word mole. Mole can be abbreviated MOL. That's so dumb because molecules doesn't have an abbreviation. So I just want you to know when you write down your final answer for a quiz or a test, make sure you write the word molecules out. And if I abbreviate something as MOL, it's moles, not molecules. I don't know who came up with that, but that's so dumb. Okay, so now we're going to have a conversion using Avogadro's number and then 1 mole. So we start with molecules. So where does molecules go in this conversion? Denominator. How many molecules are in 1 mole? 6.02 times 10 to the 23rd. Okay. And guess what? This is a scientific notation number written in the denominator. We have to watch our order of operations. So when we put this in a calculator, we need to put parentheses around Avogadro's number. Okay? So I just want to mention that. And then I need someone to give me that answer. All right, what was your answer? All right, 0.00068. And our unit of molecules cancels, so this is going to be moles. You don't have to write bromine here, but I probably would have. So that is what y'all should have gotten. Yes, ma'am.
I did not get that.
So what did you get?
He got 2.4682. I don't know what I did.
Okay, it looks like, so do you see how this is a times? You may have multiplied times that, but what you're doing is you would multiply times 1, but I usually skip that part. So timesing by 1 isn't going to change the value. And so then you would just divide by the denominator. And I didn't actually say that. For some reason, I just kind of zoned in on, okay, we're dividing. And then I didn't explain that. Yep. So you could do 4.10 times 10 to the 20th times 1 divided by, so this line means that you're doing a division. It's just disguised as like a fraction. And then the denominator amount. Yep. So anybody else have questions? No? Okay, does this sound like look pretty easy so far?
Yes.
And it's always going to look easy when someone's doing it with you, okay? But anyway, so that is converting using going from moles to particles and vice versa. So now we're going to do a new heading. And I guess I'm going to change colors because I just used blue. So now we're going to convert from moles to mass and vice versa. Remember, mass is not an actual unit. We measure mass in grams. So I'm going to put grams in parentheses beside it. All right, so we're going to be converting from moles to mass and vice versa. Now we're not dealing with particles, and so it is not going to use Avogadro's number. It is going to use the molar mass. So now we'll need the periodic table. Okay? So let's look at an example for how this is worded. And then at the end, we're going to do a couple. And so this time we do need to look at the chemical. So first of all, you're going to zone in, and you're going to see that 8.29 is given. Our unit is going to be moles, and we got to solve for mass. Okay? So what's the first thing we always do? We copy down the amount given as our starting point, and then we set it up as a conversion. So 8.29 moles. And I am going to write my chemical formula down because I'm going to need that. Have to look up the molar mass. What is the molar mass of calcium? 40.08. And that's going to be grams per 1 mole. So the 1 mole is going to go in the denominator because we start out with moles. We want that to cancel. And then my numerator is going to be the 40.08 grams. Moles cancels. That's supposed to be an equal sign. All right? And so we just multiply across. We don't have to divide by the 1 in the denominator. So we're going to get like 300 and something. Maybe. Is it 06? 26. Okay. That's grams of calcium. You can just write grams and not write the calcium. Okay, so any questions about this one? No? So it's making sense. Would I be going too fast if I scrolled on up? Maybe. Okay. So I'm going to just write my next example down and I'll scroll up in a minute. Now I just want to show an example going in the opposite direction, and then y'all are going to work on some practice individually. In this problem, we're going to need the molar mass. So we start out by copying down, where's it at? 1.8 grams. And we're going to have to solve for moles. The grams is what tells us we're going to need the molar mass. And it's not particles, so we don't need Avogadro's number. So we copy down 1.8 grams. It's aluminum chloride. It's not wrong if you don't copy the formula down. But the molar mass of aluminum chloride, we would have to take 1 aluminum, 3 chlorines, add all that together, and y'all got 133.33, which is nice. That's going to go in the denominator because we started with grams. Therefore, the molar mass, grams part, goes in the denominator. Numerator is 1 mole. So this is going to be a division in disguise. So I need someone to take 1.8 and divide by 133.33. What you get? 0.013, and that's moles of aluminum chloride. Okay, so that's pretty much any scenario that you're going to see. and then you're going to work on practice.